Hey guys, this is the continuation of our first lesson for chapter 5 with triangle congruence. This is about the angles of triangles. Our objective for today is I will be able to classify triangles and apply the triangle sum theorem, which we'll talk about, and the exterior angle theorem to solve for missing values and sides. Okay, so first things first, you have a warm-up, and I chose to include your warm-up on your note sheet today so that you can just do it all in one spot. Go ahead and take a few minutes, maximum 4. You guys can put a timer on, Mr. L, if you wouldn't mind putting a timer on, for 4 minutes and giving them an opportunity to classify these triangles based on their sides and their angles. So go ahead and do that. Please pause the video at this time so they can have 4 minutes. Okay, so hopefully the sub went over your classifying triangles by their sides and their angles, so you guys can, correct them with the sub. I've left the answer key. Okay, so based on your lesson for today, let's go ahead and get started. Now, first things first, we need to understand the difference between interior angles and exterior angles, okay? So first, let's look at interior angles. The word interior we've talked and we've seen before. We've talked about it means inside. So when we're talking about the interior angles of a triangle, we're talking about 3 angles that are inside the triangle here of A, B, and C here. So we're talking about these angles that are right inside. Okay. Now, exterior angles are angles that when and if we were to extend the sides of a triangle, those segments, extend them into lines, we end up creating angles outside of the triangle here. And what ends up happening is these guys are called exterior angles because they are outside the triangle. Now, if you look over here at this picture with exterior angles, you'll notice that every single interior angle has an adjacent exterior angle to it, right here. And if you're looking at each individual one by themselves, you'll notice that every interior angle and exterior angle form a linear pair, okay? Therefore, this interior angle of angle A and this exterior angle that's adjacent to angle A, they are a linear pair, meaning they add up to 180. The same is true for these two at angle B, and the same is true for these two at angle C. That's something important to keep in mind as you work with triangles, because this might pop up anytime. So let's move on to the triangle sum theorem. Now, the triangle sum theorem, okay, is about adding the 3 interior angles of a triangle. Now, it's called the triangle sum theorem, which means the triangle add theorem. And like I said, it's about adding the 3 interior angles of a triangle. Okay, now this is something that you have seen before, and you have learned before. This triangle ABC here has angles A, angle B, and angle C. The triangle sum theorem says that if I were to add the measures of each of these angles, that the sum of the interior angles is going to be equal to 180. This doesn't matter if your triangle is an acute triangle, an obtuse triangle, a right triangle, scalene, isosceles, or equilateral. This is a fact about triangles, okay, in Euclidean geometry. So no matter what, the 3 interior angles of a triangle will add to equal 180 degrees. Okay, so essentially the measure of angle A plus the measure of angle B plus the measure of angle C, adding them up, is going to equal 180 degrees. Okay, this is something that you can set up with 3 interior angles of a triangle with no matter what kind of triangle it is. Okay, so if we take a look at an example here, we'll see this example right over here. Okay, we want to solve for A. Now, we're given this triangle. This triangle has 24 degrees here. It has 72 degrees at this interior angle and this is our A. That's our third interior angle that we're trying to solve for. So the triangle sum theorem tells me that if I take A and add it to 24 and add it to 72, then it's going to equal 180 degrees. So when I set this up, I can solve for A. I combine like terms here with 24 plus 72 and I get 96. So I have A plus 96 is equal to 180. Then I'm going to subtract 96 on both sides, and I'm left with A is equal to 84. Okay. So it's as simple as just adding the three interior angles together, setting it equal to 180, and solving for your missing value. So go ahead and try and solve for the measure of angle 1 here. Remember, you know this is a name because it doesn't have a degree like this one. Now, one thing you guys need to be careful with is when you see our box here, you need to remember that this box is an angle measurement of 90 degrees. So you really do have 90 degrees here and you have 38 degrees here. Okay, and you're trying to solve for the measure of angle 1. So sub, please go ahead and pause this video and give them about 2 minutes to work on this and then go over the answer with them, please. That's left for you on the answer key. Okay, so let's go ahead and continue to our next theorem of the day, which is our exterior angle theorem. Now, the exterior angle theorem is all about the exterior angle, okay, of a triangle. Now, this is true for any exterior angle. So it says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Okay, that's a mouthful. So let's take a look. They're saying that the exterior angle, the measurement of the exterior angle, is equal to the sum. That means we're adding the measures of the two non-adjacent interior angles. Non-adjacent means not touching. So we add the two interior angles that are not touching the exterior angle. So look over here. Here's angle 1. Angle 1 is an exterior angle. You know that because it's outside of the triangle here. Now, the theorem says that the measure of angle 1 is equal to the sum of the two angles that are not touching angle 1. Well, if you'll notice here, angle C here is actually touching angle 1 with this side. So angle C is an adjacent angle. The two other angles in the triangle are your two non-adjacent angles. So in order to find the measure of angle 1 here, we add the measure of angle A plus the measure of angle B. Okay, so let's look at some examples here. And what we can do is we can actually take a look at our example right below. We have a few examples to talk about. Now, I know you just want to copy things down, but I really, really encourage you to listen because you're going to be asked to do a bunch of problems on the back page. And that's going to be your responsibility and you'll have an exit flip. So let's take a look at this one here. We are trying to solve for the measure of each numbered angle. Well, out of these three angles that are given to us, this is 53 degrees, this is 53 degrees, this is our numbered angle of angle 1. Notice this is our exterior angle, angle 1. Okay, so that means that this exterior angle is going to equal these two angles added together. Now, these two angles can be added together because they are not touching angle 1 here. Notice they are like fully across from it, away from it, not nowhere near it. It's not the angle that's next to angle 1. And so the measure of angle 1, our exterior angle, is simply equal to 53 degrees plus 53 degrees, which equals 106 degrees. So the measure of this exterior angle, angle 1, is 106 degrees. Now, over here, for our second example, let's go ahead and take a look at that one. We have 60 degrees, we have 110 degrees, and we have angle 1. Now notice where angle 1 is this time. Okay, it is now inside our triangle. It is an interior angle. So when we set up our equation our angle 1, the measure is going to be somewhere different than it was over here, because now it's one of the interior angles. It's not the exterior angle. But we are given an exterior angle. We're given this exterior angle of 110 degrees. And when I take a look at the measure of angle 1, I see that it is one of the angles that's not touching the exterior angle of 110 degrees. And so because of that, I can use the measure of angle 1 and the other angle that's not touching 110 degrees, our exterior angle there. So we have angle 1 and we have 60 degrees. So I can set up an equation, and again, it's always the exterior angle equals interior plus interior. So my exterior angle here is 110 degrees. So that goes on the outside here. And that equals my interior angle, 60 degrees, plus my interior angle, measure of angle 1. Now to solve this, I just simply subtract over 60 to both sides. 110 minus 60 is 50 degrees. So the measure of angle 1 is 50 degrees. Now if you look at the U-try, yes, you see the answer. You have to show me the work for it. Okay? So I want to see the work for it, and then you can double check your answer. If you're working and you're not getting this answer, ask for help. Okay? Go ahead and pause the video so they can work on this for a moment. Now, for the rest of the class period, it is your absolute responsibility to complete the following 7 problems. Okay? Now, I have gone ahead and done number 1 for you here, because this is one of those things where we're still using the triangle sum theorem and we're still using the exterior angle theorem, but we have a little bit of algebra thrown in. Now remember, the triangle sum theorem says that the 3 interior angles of a triangle can be added together and equal 180. So in this triangle here, I know this angle is 90 degrees. This angle here with the arrow to the angle is 19x minus 1. This angle here with this arrow is 13x minus 5. So if I have all 3 interior angles represented, I can take them and add them together. 19x minus 1 plus 13x minus 5 plus the 90 degrees from this given angle is equal to 180 degrees. Combine like terms, negative 1, negative 5 plus 90, that gives you 84. 19x plus 13x, that gives you 32x. Subtract over the 84 on both sides. You get 32x is equal to 96. And you get x is equal to 3 after you divide both sides by 32. Okay. Now, you're asked to find the measure of each acute angle. So after you have found x, you then need to plug x in to each one of these acute angles to find the measure of the angles themselves. And so that's what I'm doing here. I take 3 and I plug it in for 19 times x, which is now 3, minus 1. Simplify that. 19 times 3 is 57, minus 1 is 56 degrees. I do the same thing here for the other acute angle of 13x minus 5. So I have 13 times 3 for x minus 5. That's going to give you 39 minus 5, which is 34 degrees. Okay, you are responsible for numbers 2 and 3. And again, same direction. You must find the measure of each acute angle. Okay. Next, you have find the measure of PQS. And when you take a look at number 4, you'll notice now we're not just dealing with interior angles, we are now also dealing with exterior angles. So when we're trying to find the measure of angle PQS, PQS is this exterior angle right here. So you have 3x plus 25, our exterior angle, is going to equal the 2 interior angles away from it added together. 3x plus 25 is equal to 2x plus 65. And I'm going to go through and solve this. and I get x equals 40. And then I'm going to plug 40 in for angle PQS.